Every year, when the rains arrive, they bring more than water. They bring uncertainty. They bring distraction. And for far too many families, they bring unimaginable loss. My name is Kofi Ankama-Asamoah, and I'm a final year computer science student of the graduating class of 2026. And I worked on this project with Kobina at Opei Jr. Across Ghana, floods have become one of the nation's most devastating natural disasters that occurs annually. Lives are lost, homes are destroyed, businesses are disrupted, and communities are forced to rebuild again and again and again. Yet the question remains, what if we knew before disaster struck? What if communities had time to prepare? What if technology could help us save lives? To address all these questions, we designed and implemented a data-driven flood risk prediction and early warning system for all Ghanaian communities, which we call FloodGuard.
In building FloodGuard, we developed a data-driven early warning system that combines rainfall data with environmental data such as the distance to waterway and the elevation of the land to assess flood risk into 4 major levels, which are low, moderate, high, and severe.
FloodGuard was born from one simple belief, that is, so far as there are rains, floods cannot always be prevented, but their impacts can be greatly reduced through timely information and better decisions.
To evaluate the reliability of our prediction, we tested and evaluated 4 different machine learning models and picked the best one using key evaluation matrices and its ability to predict flood risks. We collected and processed relevant datasets, analyzed rainfall patterns of 14 major flood-prone areas in Ghana. Some of these areas include Dansoman, Choko, and Alojo. With these areas, we used machine learning techniques to develop a model that is capable of predicting flood risks. At the heart of FloodGuard is our interactive dashboard, with 6 powerful interfaces that make flood information clear and actionable. First is the main dashboard. The main dashboard is basically the command center. You get to see the current risk levels, the number of areas being monitored. You get to see a map that is color-coded for each of the 14 areas being monitored. You get to see a forecast of the weather predictions of all the areas being monitored as well. That is what you get to see in the main dashboard. Next is the flood risk map. Here, you would be presented with a color-coded map where green is for low risk, yellow is for moderate risk, orange is for high risk, and red is for severe risk. You'll be able to zoom in into each of the 14 areas being monitored. You would be able to select each of the areas. When you select, you would see details of the live rainfall and the risk, whether it is safe or not. You would also get a list of all the areas being monitored. You get a mention of the live rainfall and then also the risk prediction. Next, after the flood risk map, is our rainfall analytics. Here, you would get to see a lot of visuals. The aim is to help easily understand the data that is being presented to you, whether you're a novice or intermediate user. Here, you get to see total rainfall for the past 7 days, peak rainfall. You get to see bar charts of the days within the week that it has rained. You can select the locations you want to check and analyze, where you would see maybe Alojo, Choko, or Dansoman. You can pick any of the 14 areas being monitored and you get skewed data or skewed predictions for these areas.
The Alert Center keeps a complete history of all system predictions and alerts. You can filter by region, risk level, or outcome, making it easy for emergency teams to review past events. The emergency guidance is a life-saving feature. It offers clear step-by-step instructions on what to do before, during, and after a flood, from preparing emergency kits to safe evacuation and recovery tips. The SMS Alert Center allows users to manage their phone numbers, choose preferred locations, and set severity thresholds for receiving automatic SMS warnings. This ensures that even people without smartphones stay informed.
As part of our future development roadmap for FlatGuard, we are working actively to incorporate all these factors into our system. We intend to evolve FlatGuard from just a rainfall-based prediction model into a multi-hazard system or a multi-hazard flood intelligence early warning system.
To conclude, throughout the development process, we focus on creating a scalable solution that can be enhanced with additional data sources, real-time weather information, and collaboration with relevant stakeholders for practical deployment. And on this matter, we've held a series of meetings with the Ghana Meteorological Agency, an expert in the hydrological field, and a software engineer to enhance the capabilities of FlatGuard.